Okay, we're gonna be doing another Leetcode today, team. It's your boy, the Knologist, and we got the intersection of two arrays. Given an integer nums array 1 and nums 2, trying to array the intersection between each element. The result must be unique. May return in any order. Okay, so let's go to the whiteboard first. I need to visualize how I would solve this physically, without any fancy tools and tricks. So we got 1 2 2 1 and then 2 2. Then we got 2 2. So the result must be unique. So first I'm going to go through 1 2. I look for what's common. 2 2 is common. 2 2. So the intersection would be 2 2. And then since we have to be unique, the answer would just be 2. This is one of those sliding window questions, I'm pretty sure. You have to find the window where it intersects. I'm thinking, I'm just do I iterate through the first one? I'm thinking I could iterate through the first one, or whichever one is longer. So first, this is the way I would do it. I would look for the longer one and iterate through that till I find the first element of this one, and then find a second element of the smaller one. And then if I do that, that would be sufficient. So basically, 1. Does it match this? No. Go to the next. Does it match this? Yes. Move a counter to the next. Does the next element match this? Yes. Then we get an answer. That would be my way. So first I would go okay, check. Check if one array, one list. Other Python. Why does it take so long? Control A. Check the length of two lists or compare. Compared to lists. Alright, let's do this. If L1 because it's guaranteed to be crossover at one point in the list. So for like 495, 94, you go wherever the bigger list is, and you keep iterating through the bigger list till you find the smaller list. Otherwise, you just keep iterating until you find a commonality. Okay, so this basically says whichever one's the bigger one, make it L1, is what I'm trying to do. Now that I have my sizes, I go through each element. So for and then I'll create a counter up top. It's got to be unique, so we got to eliminate duplicates. So I just make it a set, and I'll make it a list again after. L1 at I is equal to L2 counter output dot append counter output dot append counter no L2 counter append this item and if elif the counter is greater than 1 and it no longer matches the list element, then break out of the loop. Then I take this and its intersection is the set of elements, so I just make this list a set to delete any so I go then we run it. Oh, counter. Try that. Out of range. If Li equals L2 counter Okay, what's my time limit? 15 minutes. Okay, let's just look it up because it's already a long ass solution. So this is my logic was if any of these is 0, return nothing because there's no intersection. Otherwise, create a counter and an output array that you want to do. Second, I want to find out which one's longer so I can iterate through the longer one and find the intersection with the shorter one. And then if it matches, add that matched element to the output array, increment the counter, and at a certain point there might be a spot where the counter goes beyond. If counter is greater than 1 or, let's put or, greater than L2, break. Let's explicitly define lengths. If list element at I equals L2 counter. I don't know why that would be out of range. If L1 that I'm iterating through is equal to L2's counter at 0, why would that be an issue? I don't know. Oh, greater than L2, length of L2. Maybe let's try that. Still. Okay, try troubleshooting it. Let's just see what's going on here. Did I just close the fucking question? Oh no. Let me find the question again. Algorithms, easy. I hate when I do this shit, when I accidentally lose the question I'm working on and then I have to fucking find it. Okay, so this constraints. Okay, so basically if the counter goes greater than 1, that means we no longer are in an intersecting set. So then just break out of the loop, return that set, and then that way if I do set, if there's duplicate elements, it won't output it. It'll just output the unique elements. So for example, 2 would turn into 2. 9-4 would stay as 9-4. So that's my logic. So let's see where my logic goes astray. One second, let me delete this. Close that. Paste this. My code. Fix my code. Issue with your logic is when you're comparing elements and managing the counter variable the way it's set up, comparison and incrementing of the counter are not correctly aligned with the logic for finding intersections. You don't need to manually compare indices. Instead, the problem you solve by using leveraging the Python set operations to find the intersection. This handle sets as uniqueness automatically. I mean, I do that here. Let me try this before I look at the answer. Set1 equals nums1, set2 equals nums2. So now I eliminate all the other things. Then I would just iterate through them, I guess. Yep, so set1 equals nums1, set2 equals nums2. Find the intersection of both sets. So output set1 and set2. Okay, so it kind of uses that bit registry thing. That's interesting. We automatically remove duplicates from each list. Okay. Intersection using AND to find intersection between two sets. Output set1, set2, list. Ooh, so they're just leveraging the AND operators and they're just doing it that way. Let's try submitting it. That's actually really smart. That is actually really smart. Okay, let's just quickly analyze it. Let's go to Python Playground. I just want to break down how it's doing this. Okay. So this is how I'm just tracing through my understanding. So now I'm going to print set1, set2, okay, then I go AND. Compare. In other words, AND is the bitwise and operator. A and B, intersection of two sets. Read the docs, okay. And intersection. Returns a new set with elements common to the set, another set. Okay. Oh, okay, so that's how it works. So it's just like a mathematical set comparison. So you're taking two sets, it's like a Venn diagram, the ones that are in both, you just return the new set. 1 and 2 returns 2, 1, 2, 2, 3, 2 returns 2. Okay, so you're actually taking physical mathematical sets and returning them. And then they're just returning it as a list. So you take the output here, you turn it into a list. Boom. This is actually a really, really efficient way of solving. Wow. Like, I learned something new today. So beats 59.32% of other solutions. If you like this video, give it a thumbs up, subscribe, and comment below. Knologist out.